Just as a disclaimer, I've had some requests for people to be able to view this later, and I asked Tim's permission earlier, and we're going to record this meeting. So don't see anything that would embarrass you in front of your mother. Thanks. Welcome, Tim.
Hello, John. It's great to see you and the rest of the club members down here. I'm in Western Pennsylvania, where we have a little bit of a heat wave going on. It's actually over 50 degrees tonight, and you won't see 50 degrees until next June, maybe July. I spent a lot of time in Alaska. I used to work for AT&T and Cellular One, and we had the entire state of Alaska. So I have been to Fairbanks, I've been to Two Rivers, I've been to Delta Junction, I've been to the North Shore. So it's great to see everybody. And let's talk about grounding and bonding tonight, John, if you're ready.
Yes, please.
All right, I'm going to share my screen here, and we will get this started. John, you're going to have to let me know if you see my slides okay. I think there's been some changes with Microsoft, and so it says my screen is paused.
Well, we're seeing your slide, and we're seeing the list of slides in the left-hand window, which is fine with me, but I just wanted to make you aware of that.
Yeah, that's no good. Let's try again here.
There we go. Now, yep, now we're in the presentations window.
Okay. And you see my second slide?
Goals of the session.
There we go. Good. All right, we're going to do some things here tonight. I'm going to try to convey to you the difference between grounding and bonding. I'm going to show you some techniques. I'm going to show you how a system approach works, and I'm going to leave you with some resources as well. And because you are recording this, you can go back and take a look at these resources from the ARRL handbook and the antenna book. One of the best books on this subject is the Grounding and Bonding for Radio Amateur that N0AX has authored. There's also a lot of online resources. The Motorola R56 guidelines, it's over 500 pages, but it's really good. And also Kilo 9 Yankee Charlie, K9YC, has a great website. And there is no such thing as an RF ground. There are ground loops, but don't worry about them. And I'm going to really focus in on single point grounding, which is really single point bonding. And in Alaska, it's tough to drive a ground rod this time of year. So we're gonna talk about a lot about bonding, which is really meant to keep 2 points or even more than 2 points at the same voltage. It's not expensive, it's not hard, and it works in your favor for AC safety, lightning protection, and RF management. And for bonding to work, it has to be low impedance and short at the frequencies of interest. It's got to be sturdy enough to survive the environment, and Alaska is a challenging environment. I like to use heavy strap or heavy wire, number 14 or larger. The flat weave braid, tin copper braid, is good for inside the shack, but no good outside at all. And you cannot use braid from old coax inside or outside because it deteriorates very, very quickly. And we're going to really focus on safety and making sure that you know how to wire up your house or hire a professional electrician. That's really the best way to do it. AC safety grounding has a lot of names: equipment ground, third wire ground, green wire ground, and this provides a path to the AC common point for fault currents, and it also stabilizes the AC power voltage. And here's how this is all wired up. Outside your house, you have a utility transformer that steps down about 4,000 volts to the 240 volts with a center tap to give you 120 volts. and that comes into your house. And then inside the breaker box, the main breaker panel, there's a neutral bus and a ground bus. And the only place that they should be bonded together is inside the main panel. If you have sub panels, you do not bond the neutral and ground together. And of course, the ground has a grounding electrode. And this is right outside where your breaker box is. I like to use the exothermic welding on the ground rod. That is the best way to go, but you can use the clamps, but exothermic welding, and we have these one shots at DX Engineering. And the idea is to bond all your earth connections together. So you have your electrical panel and all of the other ground rods are all bonded together. And lightning is not a huge problem in Alaska, but it does happen. You want to make lightning stay outside of your house and make good decisions. And the idea is you don't want lightning to have to go through your station on the way to Earth. You don't want to do this, not ground your tower and then invite lightning in to go through your radio. That's a very bad system. You want to keep the tower on ground. You want to keep the coax on ground. You want to keep all your radios bonded to the outside ground system. And this keeps lightning outside of your house. And if you have a tower, you want to make sure it's well grounded, and you want to bond your feed lines to the tower. And if you have a vertical antenna, you can use spark gaps across the insulators. And a single point ground panel is very important. Here you'll see the RF ground plane underneath the radio equipment, and then the RF ground plane is bonded to the single point ground panel. Here's some good lightning protection devices, gas discharge tubes, etc. Here's an example of a single point ground panel showing the lightning arresters and also showing gas discharge tubes. That those are the blue items there on the right for the rotor control cable. And another example of a single point ground panel, and making sure that everything has a common bonded connection. And bonding inside the shack, each piece of equipment is hooked to the RF bonding bus. The RF bonding bus is then hooked to the single point ground panel. Remember that everything inside your station is an antenna, and you have to make sure that you have a good common bond. And then if you have any problems, you may need to use ferrite in there as well. And you want to concentrate on bonding, equalize the voltage, eliminates hot spots, reduces RFI, reduces sensitivity, and minimizes audio buzz and hum. And the RF management, we want to keep the cable short, minimize the loop area, keep the cables together. Here's an RF ground plane underneath the radio. This is a sheet of metal. It helps equalize voltages, and you run your cables along the ground plane and you bond to the station ground system. Remember that all currents flow on all wires. A single solid ground system made of short, heavy, i.e. wide, direct connections satisfies all the requirements for AC safety, lightning protection, and RF management. Here's another example showing all the ground rods that are outside the station. They're all connected together. All the ham radio equipment is connected to the RF bonding bus, which is connected to the single point ground panel, the SPGP, which is also connected to the AC power panel, which is also connected to the tower ground. Showing the ground system connections from the SPGP, the AC service ground electrode, and the bonding bus that goes to all of the equipment. These are great online free resources from the National Fire Protection Association, from Polyphaser, also from the FAA, the IEEE, And the ARRL has great resources on arrl.org for electrical safety, grounding, and lightning protection. Also look at WHAI. And remember this ground plane. This is really important. And here, this is a K3LR. This is my friend W3YQ. And we're putting in the copper RF ground planes. And then this is the connection to the single point ground panel. And the strap is going down to the ground rods. And here's the strap coming to the number 2 tin copper solid that is on the ground rods. And then all the connections from all of the equipment onto the single point ground panel. And here's the RF ground plane getting ready for the equipment. And you can see the connection to the single point ground panel. And then the radio is put on top of the ground plane. Here are 2 radios, 2 ICOM radios on the ground planes. And then there are connections to the single point ground panel. You can see here the connection of the ground plane using this is 1-inch wide tin copper braid from DX Engineering connecting on the back of the radio. And then from an amplifier, the 1-inch wide tin copper braid connecting onto the RF ground plane, and then the RF ground plane to the single point ground panel. More connections from more amplifiers onto the RF ground plane. And that is my presentation. And if you have any questions, I am certainly here to see if we can answer.
Well, I'm going to take advantage of the opportunity, and I have told fellas here that for a while now, I'm in the process of putting together a new ham shack. I actually I live on 5 acres, 30 miles east of Fairbanks on Chena Hot Springs Road. So I have the space to put up a building and a tower, which I did after I retired 6 months ago. So I've got a nice 16 by 24 cabin and a 70-foot piece of room 45. And so I've been trying to follow some of these guidelines for the grounding. And so I've got a ground rod at the place where the electrical service comes to the cabin and the sub panel is mounted. And the cable entrance through the wall of the building is on the same wall just underneath the service panel. And this is Chris KF7P Metalworks ground panels. So I'm using, I think, number 4 bare copper electrical wire under lugs from the electrical panel and the ground panels. And then through the wall, I've got metal conduit with grounding bushings, and the wires are connected to the grounding bushings, both inside and outside. And it's all tied to a single ground rod right outside the building. And I've spent a 40-year career as a broadcast engineer. And so I'm very hip to, you don't put the antenna on one side of the building and the AC power service on the other side, because what's in between is all your equipment, and you don't want the current flowing through there during the lightning strike. So I figure this is probably the best I can do to keep everything on one side of the building and hopefully keep that in abeyance. And then inside the Metalworks panels, I've got the surge protectors. And I hadn't seen the example that you used for the ground planes under the radios. I might want to discuss that a little bit. And then I haven't cut this to length yet, but that chunk of number 6 bare copper, and it's stranded, by the way. I've got a coil inside the building. I was going to run it over one to the workbench and one to the radio desk, and I stumbled across the photo of using a piece of copper pipe, whether it's half, 3/4, 1 inch, whatever, and some of those clamps, and then put the pipe down the length of the back of the desk and use the clamps to clamp on and have the screws on there, and then run the braided bond over to the piece of equipment and have that piece of tubing tied to that that ground wire coming in and bring everything together at that ground rod outside the building. So that's my setup basically. So I'm curious about the ground plane under the radio. And the other thing that I'm curious about is at my tower, I individually I put 3 ground rods around it, and I tied each of the 3 tower legs to those 3 ground rods. But don't have bonding between the tower and the building. They're about 100 feet apart. So, in a broadcast installation where I'd say have a 10 or 50,000 watt medium wave transmitter in the building and antenna tuning unit and a series fed vertical antenna, I'd sure run, heavy 4-inch copper strap between them, but I haven't done that here. I have another KF7P Metalworks panel at the tower, and it's got bulkhead connectors so that the coax shields are grounded at that point, and that's tied to the tower and to the ground rod. So I'm not sure, other than the coax shields and the ground rods, that everything is really nailed to the same potential there. But I know how expensive 100 feet of 4-inch copper strap is, so I haven't done that. And but I've spent enough money on the rest of it. I could be convinced, but we're not in a high lightning area. So I'd kind of like to discuss a couple of those points that I brought up, and that might help me, and some other people might get some information out of it, and we'll generate a little discussion.
Yeah, so John, putting the RF ground planes underneath the radio equipment. So I have underneath all the radios, all the amplifiers. This is a well-known practice that is discussed in the Ward Silver book, Grounding and Bonding for the Radio Amateur. And this is an effort to keep the voltage potentials at the same voltage point. And it also equalizes a lot of the variations that are going on. It's been an incredible thing here. First time I saw it was down in Brazil, and we had some temporary installations that we had RF ground planes, and that really took a lot of the issues of sensitivity of the equipment placement out of the equation. So I would suggest that you get the Ward Silver book. He has a whole chapter dedicated to the topic of RF ground planes, and I would definitely bond your tower to the rest of your ground system using at least a number 2 wire, if not 2-inch strap between the two. I use 2-inch strap between all of my towers and the common ground system here.
So I do have Ward's book. I don't recall reading the piece about the ground plane, but so I guess this is why we have discussions like this, so that we can learn stuff. And so thankfully, like I said, we don't have too many issues with lightning in Fairbanks, although I have seen it. And but I don't know if anybody has stories to relate about amateur radio equipment and lightning in Fairbanks. I have some broadcasting stories, but anyway. So we've had several people, we've kind of put out a survey, and I know that you had a list of things that you have prepared presentations on, and we had several people ask specifically for this. So I want to back off and let some of the other guys who had requested this topic to maybe pose some of their questions. So I know, let me look at the screen here and see who's. So I think that maybe Roger was one of the fellows that asked about grounding. Did you have any particular questions or observations or information you're looking for?
Well, not really. It was really interesting. And I noticed up north at my other house, I have 4 ground stakes around the antenna and around the house up there. And when they're not connected, I've noticed I've got almost a full volt between some of the ground stakes when I put a meter on them. And I always thought that was pretty interesting. So around here, I've got mine grounded pretty good, but I'm going to add that copper ground plate underneath the radios and try that. And I've also noticed I ground to my, I have a hot water system in the house. So I ground to the hot water system too.
You're talking about for your radiant heat?
Yeah, radiant heat.
Okay.
But I've also noticed I've had some corrosion between some of the joints now. So I don't know if that's caused by a voltage that I'm sending through my system or not. It's just kind of interesting.
Might happen anyway.
Yeah, I think it happens anyway. They say it does with water heaters, but
Yeah.
I've noticed it. I do some furnace work too, and this grounds are just interesting.
Hey, John, on that corrosion issue, I've talked to a friend who's a professional retired plumber now in Fairbanks, commercial for the military or for a lot of DOD contracting over the years. And he said that was an issue he had to consider every time he installed something, was electrical grounding things interacting and causing a lot of corrosion at various fittings. So there are specific requirements for that he had to take under consideration.
Do
Now,
you recall any of the mitigation? I mean, we hear the phrase cathodic protection tossed around a lot, and I know it's used in the marine environment quite a lot.
Yeah.
But I also know that it's used on the Trans-Alaska Pipeline.
Yeah, exactly.
Because it's a great transformer secondary for all that energy coming from the sun, and there's a lot of current flowing through there. So, but I'm wondering about the domestic landlocked installations that those heating systems. I changed mine over to all PEX tubing about 5 years ago, so I don't have that issue. But
It is an issue with copper.
you recall what things that you maybe had recommended to be done to help mitigate that, or you just have to kind of
Not right off. I had an issue. I bounced an issue off him. I had a brand new water heater installed. It's a gas water heater, and the anode rod. Well, my indications were a lot of buildup of pressure, intermittent pressure in the hot water only. And after calling the guy who installed the hot water heater and the company, the owner finally said, well, Bradford White had issues with the anode rod and certain water heaters. The anode rod was made out of the wrong material, and the magnesium was deteriorating and causing gaseous particles to be produced in the hot water heater and causing a lot of spurting and pressure. Every time you turn the hot water on, it would spurt. So they came out, took the anode rod out, put a new one in, and in 2 months, that anode rod almost dissolved completely in that hot water heater. It was a 1/2 inch diameter, 5 feet long, and it was just about gone. So they put a new one in, and it was all so that's just in a reaction here with the material and causing corrosion that way.
All right. We've had a comment in the chat asking a question, which I think is a good one, and I've had people bring it up to my attention from time to time. Surge protecting inside or outside the shack.
Yeah.
I have mine in the panel outside the building at the cable entrance point.
And that's the best place for it, John.
So I know some other folks have it just inside the building. So like the coax might penetrate a weather boot, and then the protectors, the polyphaser, the alpha delta with the stud are landing on that that copper bar bracket, and say you might terminate your coax there and have that be your grounding point. And I don't think that's probably terrible, and it certainly keeps them, your connections out of the weather. I guess my best advice is you don't want them 25 feet inside the building.
No, not at all. You want them as close to the outside as you can get, but I understand, the challenges of weatherproofing. So if it's just inside and you still have a good connection to a ground rod, you're okay.
Yeah, and you mentioned that you had some work experience in the cellular industry, and you see that in different ways. A lot of two-way radio operations, I see they'll have some type of weather boots, and this thing will happen, and they'll ground it all just inside the building. And then other folks, and I think AT&T is one of them. At least their current rule of thumb is all the lightning protection has to be outside the building.
Yeah,
and
that's preferred.
So, and they've gone to the extreme of coming down off of the tower and putting one of those what winds up looking like a Christmas tree full of polyphasers bolted to a ground rod and then jumping into the building. And I have mixed feelings about that approach, but I understand that they certainly don't want that current flowing and equipment inside the building. In my discussion with ordering my panels for my new station, I had thought about the idea of putting surge protection where the cables reach the bottom of the tower from the antennas before they headed over to the shack. And I'm wondering what your school of thought is about that. Is that a reasonable alternate location? You know, belt and suspenders, put it there and at the building. Put it there and not at the building. I think maybe I wouldn't do that, but
Yeah, I like having the protectors right at the base of the tower.
would you, so, you know, some people have their tower right next to the building. Okay, I chose the place I had to build a tower and the place I had to build a building weren't in the same place. And so mine are about 100 feet apart. So if they're that kind of distance apart, would you put them in both places?
No, I put them in the right place. I'm an electrical engineer. There's a right place and there's a not so right place. And the right place is at the base of the tower.
Okay. So when I made my comment about putting mine on the outside of the building, you know, you seem to indicate that was, I think maybe it's just that it was preferable to having them inside the building. But in a case like I have and other folks have, where their towers are not immediately adjacent to the building, can you discuss what your thoughts are about why at the base of the tower would be? But I'll tell you frankly, Chris at Metalworks told me the other way around.
Oh, well, I can't speak for him.
No, I understand, but this
you
is
know,
so we try to get it and gather information so that, you know, we can learn more and make better stations.
Right. But I mean, it's just like having 2 or more wristwatches that tell different time. I mean, you know, everybody has their school of thought. My experience, my knowledge is based on science. And 25 years in the cellular industry as a chief technology officer. So I'm not a lightweight. I don't know what others' experience is, but I can tell you this: in installing over 3,000 cell sites, we have the lightning protection at the base of the tower. And why is that? Because that's the soonest we can get to ground. 100 feet away from there is not the soonest we can get to ground. So I will challenge anybody that says, well, the best place, if that's the only place you can get it is right at the building, then great. That's the best you can do. But if you want to have the best place, it's right at the base of the tower where those feed lines come down the tower. They're bonded to the tower. The tower has a ground system. And right there is the place to get rid of lightning. Right there. Don't invite it another 100 feet down the road.
Hey, John,
Ed,
I have seen lightning in Fairbanks take stops off the wall. I have seen, and you talk about water heaters, anybody that has 2 flex connectors on a water heater, those are dielectric unions. I've seen on the big, being a plumber for 50 years, I'm not an engineer. I've seen them out on the base where the copper was so thin coming out of tanks, you could squeeze it with your hand because they weren't grounded. They were grounded in the building, but they weren't grounded on those big brass tanks where the water came through and came back out for heating sixplexes. And it's all this electrolysis. Nobody thinks about that with water traveling through copper pipes or any kind. So, I mean, both my towers are at least the grounding system. My feed lines aren't, because my other tower's way out the back. But I put 2 ground, and it may not be right, but I put 2 ground rods in the deal and tied those to the tower. I've never had a bit of problem with any of my stuff so far in the last, of course, I've never had a lightning strike either, but
I think the comment in regards to the heating system was bonding the grounding for the radio equipment to the heating system going to exacerbate the potential for electrolysis or cathodic erosion? And I think the answer was probably no. Not that you shouldn't pay attention to that, but radio wasn't making it worse.
yeah.
I think that's the takeaway from that.
But I mean, you watch all this stuff, even in your own homes. That's why they put those anode rods in there, because they put dielectric unions. Those flex connectors are dielectric unions. So there's no way for that to go anywhere. Just a thought.
Hey, I got a question about the lightning arresters itself. What's the advantages or the differences between the gas tubes and the open spark type? Which one
Well,
might be better?
Yeah, it's really religion. They both achieve the same end result. All right. So whether you have the spark gap or you have the gas discharge tubes, they're both very effective. So don't worry about it.
Okay.
Have any experience with the, it seemed like the idea, particularly if you're in a lightning prone area, that something like the alpha deltas with replaceable plugs might make life a little easier than a polyphaser, which would require the replacement of the unit if you just unscrew that plug and replace it.
No, you're right, John.
Yeah. So I think I get the plug on my alpha delta coax switch, but mostly my introduction to the lightning surge protector world was polyphaser, like a lot of guys, and I haven't had to replace one, but that doesn't mean that it couldn't happen. So I invite additional comments from folks. So this is your opportunity to stir up a discussion and maybe get your situation figured out to have the best setup.
So I've got a question actually. My tower is grounded with an 8-foot rod, and I have that ground carried into my shack with a very large copper and then tied into my radio. And then my radio is actually powered by a 12-volt battery. So it's not connected to the house. However, I have the capability, and in the past have tied or actually run my base station off of a regular power supply.
Mm-hmm.
Should I tie my tower to my house ground? At one point, I was under the impression that I shouldn't do that. But does it make a difference? Should I?
Yeah. If you don't tie it to your house ground, which is the ground that is connected to your breaker box and to the ground that is part of your electrical system, you will have a difference in voltage potential. You have to tie those together.
Okay, excellent. Thank you. My next question is, we talk a lot about lightning, and we do get some lightning up here in Fairbanks and North Pole. But what, if anything, can we do about potential issues with, let's say, a solar flare or an EMP, where there's inductive currents and things like that? How do the grounds impact that, if at all?
All bets are off, and the best protection is to disconnect your equipment.
Okay. That's
I would kind of
what I
divide
thought.
that conversation into 2 topics and address the EMP separately. Not that it shouldn't be addressed, but in terms of the solar flares, I guess I'm not of the understanding that anything that we've seen or are likely to see falls in the category of destroying radio equipment. What do you think?
Well, you know, when 2025, 2026 happens in a solar peak, there is possibilities of events that will affect the electrical grid. And if it's strong enough to affect the electrical grid, it's strong enough to wipe out the front end of your receiver. Disconnect.
Fair enough. Oh, certainly safer. You know, I'm not going to dispute that part. Let's all hope that the word Carrington remains a historical word.
But let me just ask this. So disconnect is one thing. I mean, obviously, is there any sort of protective circuit or anything, you know, that you can do besides complete disconnect? Because frankly, you know, during a solar flare, an X-ray flare is going to come at the speed of light. We're not going to know ahead of time. Whereas we will know with, you know, something beyond that, where the basically the follow-on at a day or so later, but we won't know initially. Is there any sort of circuit that we can do besides just keeping our radio unplugged unless we are going to actually be transmitting, that we can do to protect ourselves? Is there anything that we can do along those lines as far as grounding or circuit breakers or anything like that?
No.
Okay, thank you. That's easy.
So I'd like to expand on Kevin's observation for a minute, because I had the same problem with the shack in my house before I built the building outside. And that is, the electrical service panel is on the opposite side of the house of the antenna entrance for my ham shack that's in the house. And so I think the answer is you want to have a station ground, and you want that to be grounded to your electrical service for the home. But I'm thinking also that you want to have a ground wire driven in the earth just outside the house, and get a ground wire of some nature to it, so that anything that's coming on your antenna that's going to your surge protectors has an easy path to ground. That's not necessarily through the ground bus of your station and through the ground wiring of your AC power circuit back to the electrical panel on the other side of the house. You don't want the circuit to be through your radio.
Right.
So,
I showed that very early on, how you do that.
yeah. Well, Kevin brought up the point, and I have a personal experience with it. So I think not everybody has the opportunity, of course, to either put their radio cable entrance next to their AC power entrance, or build a building with it that way, where you can bond it all together and have it be really short. So, you know, you do what you can do. This one here in my second bedroom converted to an office with ham shack and built in the closet, right? So, you know, that's, I'd say, probably pretty typical for a lot of guys, but there's things that you can do to help yourself.
Tim, this is John from Delta. How often do you recommend people, I don't know how the ground is here, how often do you recommend people pull their ground rods and take a look at them?
Well, you know, John, that's a great question. I don't think you have to pull the ground rods, but you have to make sure that when you install the ground rods, that you use a good quality ground rod, because you know, it's typically made of steel and it's copper clad.
Right.
So, you know, John, if you're seeing rust of any sort on the top of that ground rod or anything like that, then I would question it. Otherwise, and again, exothermic welding or CAD welding is the best way to connect to those ground rods, not with mechanical clamps.
Right.
And so as long as you're doing that, John, I think you're okay.
Well, the reason I asked that, I'm actually from Florida, and we can drop an 8-10 foot ground rod and come back in 10-15 years and you got about 2 foot.
You got a lot of lightning there too.
Yes, you do. That's true. It does, and it weakens it. But the ground's very acidic in a lot of places, and
Right.
even just a rock scrape on the copper cladding will give
Yep.
the stuff access to the metal behind it. So
Yeah.
Well,
That's
let me pose a suggestion to you, John, and that would be if you can reach the ground rod, assuming it's like, you know, just with your physical strength, if you can grab it and pull on it, if it comes out, it's not good. Right. So
generally, that's a good statement. But
yeah.
I used to work for Time Warner, and I've been to many new houses and stuff. I just clamped a pair of pliers on it, rattled a little bit, and pull it straight out of the ground. So I'm not as small as most people, but generally that's a good question, good statement. But I used to be in the business making sure cable and TV and stuff was grounded when we went into a new neighborhood and stuff. And I've been back into those new neighborhoods 8-9 years later, still working on the same company, checking on something why the picture's going bad and faulty ground, and they're getting traffic back. Things are trying to find another way to ground. So, it's just, I do like using those splices that terminate the ground. At the tower where you use the two double connectors and splice into the ground. Yeah, I do like those. I use those all the time.
So, Tim, aside from the CAD welding, I had seen some guy that was posting some YouTube videos. I think he's in Eastern Oregon, like Ham Homestead or something was his little channel. And he had a nice portable Milwaukee hydraulic press type. I forget the brand name of it. I don't know if it was Erico or something for the connections. And so when you'd squeeze the heck out of this thing with a hydraulic driven press, that you could achieve a really good connection between the ground rod and the ground wire that was meeting the rod. Are you familiar with those at all? And what opinion might you have of that?
No, I know there's a lot of other types of ways to try and get around it. I'm a very basic good guy. Weld it, one shots, they work. Period. I don't want a mechanical connection there.
If you happen to stumble across this, it might be worth taking a look at. I think it was
I'll look at it.
Yeah,
but
it was very much different than
if
I'm just going to put a screwdriver on it and tighten it up
Yeah.
kind of thing.
There's no free lunch in this thing. If you want the real deal, and if you look at the standard specs, if you look at what Motorola and what AT&T and Verizon and T-Mobile are doing, they're all doing CAD weld. They're not doing any funny stuff. So I'm going to go back to what I know works and what survives.
I got to ask Tim a question.
Go ahead, please.
Okay, hey, Tim, I'm down here in a W6 land. Oh my God. So I'm in one of these gated communities, which is pretty hard to put up antennas, if you know what I mean, which my neighbor on one side's got a palm tree, said no problem. Neighbor on the other side's got a tree, said no problem. But to make it permanent, I can't do. And I ground my long wire. Is there any antennas out there? And like one of the guys said that runs the HOA, he said, put it up. If you get caught, you ask for forgiveness. But is there any vertical antenna? And I'm only down here $5, so I want something I could take in and out. That's good that you don't have to run ground. I mean, you don't have to have a ground system or a poise system for them.
Well, that's a great question. And unfortunately, I'm going to go back to there's no free lunch. And a vertical antenna needs to have a ground system. Even the ones that you see in QST and CQ that say no ground radials required, they need a ground system. That's the other half of the antenna. Right. And if you don't have a ground system or a radial system, you end up with a hot coax, you end up with RF in the shack, you end up getting bit on the microphone. I could go on and on. So there's no real free lunch here. But if you've got a palm tree and you've got another tree, you can get up a dipole antenna, which is a balanced antenna. You feed it with coax, it's resonant, and you can work the world with that piece of wire.
Well, I've got a long wire and it gives me everything I know, but it gives me more than one band. You know, you get to pick out what band you want.
No, I get that. You can do that with an open wire fed dipole too. If you take an 80-meter dipole, feed it with ladder line, get a good ladder line tuner, you can go from 80 meters through 10 meters every band, and you won't have any RF floating around because it's a balanced system.
Right.
But I get, not every situation is great, and an HOA is a very, very challenging deal. So you kind of have to play the hand you're dealt.
Well, and it nobody sees it. I mean, the way it's hooked up, you wouldn't believe it. Palm tree to the stack, the fireplace over to another tree. Nobody sees it, nobody cares, and the neighbors don't say anything, but it's not like the beam antennas up north.
Well, hey, as long as you're on the air, having fun and working, guys, don't worry about it.
Yeah, okay, thanks.
Thanks, Ed. Anybody else have anything for Tim this evening? Well, Tim, it's coming up on the hour, midnight witching hour for you. And I'd like to thank you for staying up late with us on a Friday evening and having some discussion with us. And it's wonderful that you've helped us learn a few new things. And we've been doing a lot of this, of course, in the last couple of years. And we started doing the Zoom thing. And I think we probably have had the opportunity to bring in several external presenters that just wasn't happening when we were meeting before in the school classroom that we were doing, with some local guys standing up and giving slide presentations or writing on the whiteboard, which is great. We have some smart fellows locally, but it's good to mix it up, and it gives us the opportunity to bring some other people together here. So we have folks spread across the state and people with a local connection that maybe winter or even have moved outside, as we call it, outside of Alaska. So it's really, in some ways, it's been beneficial to us. So I want to thank you again for joining us tonight.
Well, John, thanks so much for inviting me to come and speak to the club. And as I mentioned before, I'm a big fan of Alaska, having worked in Alaska for over 10 years in my previous career. It's been great. And I want to thank all of you who are DX Engineering customers for your loyalty to us, and that we're trying to make sure that you get everything you need. And to those of you who are not DXE customers, give us a shot. I think you'll be pleasantly surprised. We do ship out of Sparks, Nevada, which is closer to Alaska, so it's not it's not a long way away. And we do have a tremendous inventory in Sparks and also in Talmadge, Ohio. And the guys on the phone, over 400 years of experience. If you have questions, you can always call us. And if you have a problem or a question, you can always get a hold of the CEO, and that's me, K3LR at dxengineering.com, and you will get attention, believe me. So again, John, thanks so much for having me here this evening.
All right, thanks again, Tim.
All right, 73, I'll let
Thanks,
you go. Off
So,
to 10 meters.
Is it 63 because I can't afford it, or 83 because inflation's so high?
73.
No comment.
All right, good night, everybody. Happy holidays to you. See you next month.
Hey, it's gonna snow here.
It's gonna snow here.
It is
But
snowing
you
here.
guys
It is
don't
snowing
know
here.
that, but
Is it,
it's
Mike?
gonna, They
Yeah, I
said,
was in town this afternoon with snow
I'm
and
gonna have to
snow.
wear a raincoat here next week, John.
Oh.
It's
poor people.
ugly.
Didn't move far enough south.
I know it. All right, buddy, have a good one. Guys, take care.
Good night.
John, how do we get a copy of the video?
Oh, in fact, let me stop the recording.